Okay, we now have some visual input and output, meaning I can move the player and the camera chases the player. Really basic stuff. I figured I should do these simple things first before I get the collision. Maybe next video I can do collision. So right now, I just have horizontal movement. I don't have the animation, so I just drew a bunch of arrows. So you can see whether the character is going left or right. I also have the debug red line from the center of the camera to where the camera wants to sit. The camera is not constantly following the player all the time. You only start following when there's a bit of distance, meaning there's a bit of dead zone. I think that's how Super Mario works. I think that's also how a lot of platformers work. Right now, it's just one simple mechanic, but later I can do things like look ahead, where if the character is running forward with lots of speed, you want the camera to slightly look ahead of the character. And you might also want different chasing speeds depending on whether the character is airborne or on the ground, and so on. So that's pretty much the horizontal move in a nutshell, and the cam follow. And just like what I talked about in the last video, I'm sticking to integers and whole numbers and straight lines. So if I look at the camera code, this is the camera controller. So here is the fixed update for the camera. So the camera also moves or gets updated in fixed time steps, just like what I talked about in the last video. Almost everything related to the game simulation or the gameplay will run at 60 frames per second, or I'll try to run it at 60 frames per second. Unless your machine is so bad that you cannot run this at 60 frames per second, most of the time this should work. So if I'm looking at something like there it is. I'm looking at something like here. So even with the camera, we're always using straight lines and integers so that we can stick to so we can avoid fractional numbers and prevent the pixels from breaking, and also prevent the game from having minor desyncs. Usually when you calculate distance between 2 points in a straight line, usually that would require something like a square root. In game dev, you probably don't want to have that every single frame. And in this case, not only are we trying to be performant, we're also trying to avoid fractional numbers. So this is a rather simple solution. We resolve horizontal movement, and then we resolve vertical movement, while at the same time sticking to whole numbers. So this is doing the trick right now. For now, I don't have jump yet. It'll be added soon. And the custom stuff. So let's see if I can find the fixed update. So we have the custom updater. We register the different actors. I'm not sure if you're familiar with the concept of actors in Excalibur. I'm not going to get into that too deep. But pretty much everything, almost everything in a scene is an actor. You can render it, have it, you can have it updated, you can have it do physics simulations, lots of cool stuff. But I'm not going to rely on that too much. Again, I want some certain amount of control in my game. In this case, one of them is fixed updates, where I control how many frames or how much you want to advance the animation per fixed update. So I would need a custom updater for that, which is in this case fixed updates. I also have the game context to save a lot of stuff. Let me see if I can find a good example. You can see that the update just runs through the game context. This is very similar to my fighting game. The whole structure is very similar. It's just what I feel like is good for smaller games like this, games with smaller scope. So you can see the fixed update here. Oh, the animation player. One of the things that I kind of focused on recently is my own animation player. You could run it through an actor in which is provided by Excalibur, and you can just run your animation, and most of the time it would work flawlessly. The only difference here is that I want to advance in an animation per fixed update. So in order to do that, we have frame-based animation. Let's see. There isn't too much to talk about other than what I just said. Okay, so we advance 1 frame per update, which is why, again, we have the custom updater as well as the custom animation player. We can also set speed. So, oh, I'm sorry, we're not advancing per fixed update. We're advancing based on the fixed update, meaning, so right now I can choose to advance the runner animation once every four fixed updates. I might be able to find it. Forgot where I put it. Oh, here it is. So in case with the runner, we're advancing it every 4 fixed frames. If you advance it every single fixed update, that would be way too fast. So if I go back to the example. So I think the idle is also 4 fixed updates per animation tick. Same with the arrows. I only drew a bunch of arrows to kind of see the animation and get a feel for it. I intentionally put high speed for the runner and slow speed for the camera so I can see that it's working, that the camera's chasing the player nicely. I might have some sort of an equation where you have higher speed if you have higher distance. That would make the camera slightly more interesting other than just a linear follow. Certain things don't have to be pixel perfect or based on integers. Things like the X here, this is just a debug line. This has nothing to do with the gameplay. This is just for me to have a better feel for what's going on with my code. Same thing with the line and the grid. The grid, the drawing of the grid itself has nothing to do with gameplay. So I'm just using something like 0.1 for the grid thickness, which is gonna give me inconsistent fuzzy lines. I'm not sure if you can see it through the recording, but I see it on my monitor. The lines get kind of fuzzy once you start breaking down into smaller fractional numbers. Same thing with the X and the line here. But those things are not related to the game simulation, so those things are fine. They're okay to not be pixel perfect or based on whole numbers. Personally, I like having these on, even if I'm playing a game built by someone else. I like seeing the debug lines. That's just me. Obviously, for the actual gameplay, you can choose to turn it off. It would be turned off by default. Okay, so not everything has to be pixel perfect. There are things that are not related to the gameplay itself. sometimes, so this is what I've been thinking. I could have fractional numbers in terms of rendering, but I chose not to do that. I could have integer-based gameplay while having the render do something like 1.1x, 1.2x, and so on. I could do that, but at the same time, my own argument against that is I try to give you what you see is what you get. So if the gameplay is based on pixel perfect idea, if the game is based on whole numbers, I think the renders should represent that as accurately as possible. So that's why I'm trying to stick with pixel perfect whole numbers in terms of rendering as well, not just the gameplay itself. So hopefully for the next video, I might have a bit of obstacle or something in the environment that you can interact with, that you can collide with. Right now, there's zero collision. And again, the colliders will be custom written specifically for my game. And I think that's it. Oh, when I start creating the environment, I think I'm gonna base individual blocks to the grid. So I might have an editor where anybody can start creating their own level, start doing their own level design. I don't think you should be able to place anything at any pixel that you want. I'm heavily influenced by Super Mario 1, where everything is placed in somewhat bigger blocks than most modern platformers. The player can move in terms of pixels, but the placement of individual objects, I think I would keep those things simple for this game. Maybe I can try other things later, but for this project, I would like to keep things simple and keep the environment, the individual blocks snapped to the grid. The grid side is, I don't think it's too big. So I think individual grid size is 8 right now, 8 by 8. So the when you do level design, stuff like individual blocks will be snapping to 8 by 8 blocks grid. So that's it for this video. If you have any questions, you can reach me. I have all the links below. Thanks for watching. See you next time.